Hello friends, welcome to lecture number 6, matrix algebra. In the previous lecture we have seen that what is meant by transpose of matrix and we have to take two examples on it. Today we have to also take one more example on transpose of a matrix. So let us start with first example. Let u vector become -2, 3, -4 and v vector become, this is your column vector A, B, C, this is your column vector. Then we have to find u transpose v and v transpose u. Okay, we want to find u transpose v and v transpose u. Okay, write down solution. Let u column vector become -2, 3, -4. Then your u transpose become, this is your column vector. After taking transformation, after taking transpose of u vector, column vector become row vector. So it become -2, 3, -4. Right? This is your u1, this is your u2, and this is your u3 vector. Okay, so first we have to find u transpose v. Okay, so first to find u transpose v. How to find u transpose v? Your u transpose become u1, u2, u3 into your column vector v vector. Okay, so whatever u1, u2, u3, that is -2, 3, -4 into your column vector v become A, B, C. Now we have to take product, that is multiplication, right? So -2 into A, so it become -2 into A plus 3 into B plus 3 into B plus -4 into C. What is equation number 1? This is your first equation, that is your u transpose v. Okay, similarly we have to find v transpose u. Okay, then second to find v transpose u. Okay, so whatever v become A, B, C column vector. After getting transpose of column vector v, it become row vector, and row vector become v1, v2, v3 into your u vector become -2, 3, -4. Okay, and take its product. So what do you have? v1, v2, v3. v1 become A into B and C. This is your v1, v2, v3 into your u vector become -2, 3, -4 and take its multiplication. So how to take this multiplication? First element, and here is also first element, that is -2 into A plus this 3 into B, take 3 into B plus this -4 into C, called equation number 2. This is your v transpose u. Now from equation 1 and 2, what will you get? Both right hand side equal? Yes. From equation 1 and 2 we get, from equation 1 and 2 we get u transpose v become v transpose u. Okay, this is your conclusion. Okay, so next point we have to study some properties of transpose of matrix. Next point is properties of transpose of a matrix. Properties of transpose of a matrix. Okay, let capital A and capital B be any matrices capital A and capital B be any matrices for which addition and multiplication is defined, for which addition and multiplication is defined, then your first property become A transpose, take its again transpose become original matrix A. But your first property A transpose and take its again transpose become your original matrix A. Okay. Your second property A plus B is transpose become A transpose plus B transpose. Okay. Now third property become product AB transpose become B transpose into A transpose. What is your product third property? AB transpose become last matrix transpose B transpose into first matrix transpose, that is A transpose. Okay. And last fourth property, if R is any scalar, if small r is any scalar, then small r into A matrix and take its transpose become R into A, its transpose become this scalar R as it is into A transpose. This is all these four are properties of transpose of a matrix. Now let us do one more example on that transpose of matrix using this property. So let us observe an example. So an example, if your A matrix is 1, -3, -2 and 4, this is your A matrix is 2 by 2 matrix because 2 rows and 2 columns, and your X vector become, that is column vector become 5 and 3, then we have to find A into X, its whole transpose. Second one is we have to find X transpose into A transpose. And last third one is X into X transpose. We have to find three values. First value is AX is transpose. Second value is X transpose and A transpose. And third value is X into X transpose. Now if we have to find AX is transpose by using properties of transpose, AX transpose become X transpose and A transpose. That means this value and this value are equal. Okay. So now solution. Let A matrix become your A1 and A2. Right? These two are your column vectors. Where A1 is your A1 column vector become 1 minus 2 and your A2 column vector become minus 3 and 4. Okay. So we have to find, first find AX, then take its transpose. So therefore, how to find AX? So your A become A1 and A2 and your X become 5 and 3. Okay. We have seen in the previous lecture how to find X. Multiply by X left side by to the matrix A. That means you have to multiply by 5 to column vector A1 plus 3 into column vector A2. So that become 5 into your A1 vector become 1 minus 2 plus 3 into your A2 column vector become A2 become minus 3, 4, right? Now then simplify, then what do we get? 5 into 1 is 5, 5 into minus 2 is, that is minus 10. So you will first become 5 minus 10 plus 3 into minus 3 become minus 9. 3 into 4 become 12. So this become minus 9 and this is your 12. Now we want to take addition of both column vectors. So how to take addition? Take component wise addition. That is 5 minus 9 become minus 4. Minus 10 plus 12 become plus 2. So this is your value of Ax. Okay. This is value of Ax. Therefore, Ax is transpose become. That means we have to take transpose of its column vector. So transpose of minus 4 2 its column vector become row vector, that is minus 4 and 2. This is your Ax transpose, right? Similarly, we want to find A transpose into A transpose. But Ax transpose become, by using property of transpose, Ax transpose become X transpose into A transpose, and this value become same, minus 4 and 2. Okay. So X transpose into A transpose become minus 4 2, right? By using property of transpose of the matrix. Okay. While on this third one, this is your second one. This is your second one value, and this is your first one, right? Now we have to find third one value is X into X transpose. So X into X transpose become, what is your X vector? That is 5 3. That is your column vector. If you have to take transpose, column vector become row vector. That is 5. This is 3. Okay. So what is order? That is 2 cross 1, right? This order become 1 cross 2. After taking multiplication, then new order becomes 2 cross 2, right? The new matrix order becomes 2 cross 2, that is 2 rows and 2 columns. So take multiplication, that is 5 into 5, that is 25, right? Again 5 into 3, that is 15, right? Again 3 into 5 is 15, last 3 into 3 is 9. This is order become 2 cross 2. This is your X into X transpose. Okay. It is so simple. So today we have to take another point also. So next point is invertible matrix. Today we have to take another point. What is meant by invertible matrix? In 11th standard we have to study what is meant by invertible matrix. The invertible matrix means we have to find inverse of matrix. Okay. So that our next definition is invertible matrix. So what is the definition? An n cross n matrix A, and n cross n matrix A is said to be invertible matrix if there exists n cross n matrix, if there exists n cross n matrix C such that A into C equal to IN, such that A into C equal to IN and C into A equal to IN also, where IN means identity matrix of order n, where IN is identity matrix of order n cross n, that is n rows and n column. Then this A is said to be invertible matrix, where C is called as, where C is called as, where C is called as multiplicative inverse, where C is called as multiplicative inverse of a matrix A, of matrix A, where this C is called as multiplicative inverse of matrix A, right? And it is determined, and it is determined uniquely. This multiplicative inverse is determined uniquely. That means each non-zero matrix as multiplicative inverse is unique. Okay, this is called as invertible matrix. Okay. And next definition is singular matrix and non-singular matrix. Okay. Next definition is singular matrix. So what do you mean by singular matrix? Okay. If matrix A is not invertible, if matrix A is not invertible, then matrix A is called as, then matrix A is called as singular matrix. What is my singular matrix? If matrix A is not invertible, then this matrix A is called as singular matrix. Or in another way, if determinant of matrix is zero, then this matrix is called as singular matrix. Or if determinant of A is 0, or if determinant of A is 0, then A is called as, singular matrix. Okay, that means if determinant means 0, that means its inverse does not exist. If inverse does not exist, that means this matrix is not invertible, then this is called as singular matrix. Okay. So similarly, another way, what do you mean by non-singular matrix? What do you mean by non-singular matrix? If matrix A is invertible matrix, we have to erase only not words. Okay. So next definition is non-singular matrix. What do you mean by non-singular matrix? Next definition is non-singular matrix. What do you mean by non-singular matrix? Okay, same definition. If matrix A is invertible matrix, if matrix A is invertible matrix, then matrix A is said to be, non-singular matrix. Then matrix A is said to be non-singular matrix, right? That is, or another definition is if determinant of matrix A is non-zero, or another definition is if determinant of matrix A is non-zero, then matrix A is said to be non-singular. Matrix A is said to be non-singular matrix. Okay, it is so simple. If determinant is 0, then this matrix is said to be singular matrix, and if determinant is non-zero, then this matrix A is said to be non-singular matrix. Okay, this is so simple definition. Now let us take some properties on invertible matrix. Okay, so write down properties of singular matrix. Properties of invertible matrices. The next point, properties of invertible matrices. Right? If A and B, if capital A and matrix capital B are invertible matrices, then your first property, if A and B are invertible matrices, then first property, A inverse, take its again inverse, matrix A, its inverse, take again its inverse, become original matrix A matrix. Okay. Second property, if A and B are invertible matrices, then product AB is also invertible. If A and B are invertible matrix, then product AB also invertible, and AB inverse become B inverse into A inverse. Okay, AB inverse become B inverse into A inverse. And write down third one property, if A is invertible matrix, then A transpose is also invertible matrix. Then A transpose is also invertible matrix, and A transpose is inverse. A transpose, its inverse become A inverse and its transpose. What is your third property? A transpose and its inverse become A inverse and its transpose. Okay, these three are properties of invertible matrices. Let us write down note of invertible matrix, and then we can check that these properties. Write down note, if matrix A is 2 cross 2 matrix, that is A, B, C, D. This is your 2 cross 2 matrix. Okay. Then this matrix A inverse, this matrix A inverse is exists. This matrix is invertible. This matrix is invertible. When this matrix is invertible, if determinant of that matrix is non-zero, right? Then A inverse is exist if, when this inverse is exist, if determinant of A become non-zero, that means what is determinant? AD minus BC become non-zero, right? That means AD minus BC non-zero means that is non-singular matrix, right? That is non-singular matrix. Right? If this A is ABCD 2 by 2 matrix, this inverse is exists. When this inverse exists, the determinant is non-zero. And A inverse become, what is A inverse formula? 1 upon determinant of A into adjoint of A. What is your A inverse formula? A inverse become 1 upon determinant of A into adjoint of A. So what is your determinant? 1 upon, determinant is AB minus BC, right? And we have to find adjoint of 2 by 2 matrix. What is adjoint of 2 by 2 matrix? What is your diagonal entry? AD. We have to interchange diagonal entry, that is BA. Okay? How to find adjoint? See here, adjoint of 2 by 2 matrix is interchange the diagonal entry, that is AD become DA. What is your non-diagonal entry? That is B and C. Multiply by non-diagonal entry by minus 1, then AD become minus B and minus C. Okay? This is your adjoint of 2 by 2 matrix. What is adjoint? Interchange diagonal entry and multiply minus 1 to non-diagonal entry. Okay? This is A inverse. Okay? So by using this inverse property, what is this A transpose and its inverse? Take example. Take example. Find the inverse of, find A inverse if your A is 1, 2, 3, 4. What is your question? Find A inverse if A equal to 1, 2, 3, 4. What is this order of the matrix? 2 by 2 matrix. Okay. So how to find A inverse? Random solution. A inverse become 1 upon determinant of A into adjoint of A. Okay. So what is your determinant of the matrix? Take the cross multiplication. It is 1 upon 1 into 4, right? Minus 2 into 3 into adjoint. What is the adjoint of this matrix? Interchange the diagonal entry, that is 4, 1, multiply minus 1 to non-diagonal entry, that is minus 2 and this minus 3. Okay. So what is value? 1 into 4 is 4, 2 into 3 is 6, 4 minus 6 is minus 2. So what is value? 1 upon minus 2 into 4 minus 2 minus 3, 1. Okay. So we have to divide each entry by minus 2. Then it becomes 4 upon minus 2 become minus 2. Minus 2 upon minus 2 become 1. This is minus 3 upon minus 2. That is 3 by 2. What is last one? Minus 1 by 2. This is your A inverse. Okay. Similarly, we can take another example also. Similarly, we can take another example. Second example, if your B matrix is 3, 2, 7, 4, then we have to find B inverse. We have to find B inverse. Okay. What is this matrix? 3, 2, 7, 4. The order of matrix is 2 by 2. So how to find the inverse? One solution. B inverse become 1 upon determinant of B. What is this notation? This notation for determinant of B into adjoint of B. Okay. So what is this value? 1 upon. What determinant of this matrix B? Determinant means take the cross multiplication and middle minus sign. That is 3 into 4 minus 2 into 7 into, what is the adjoint of B? Interchange the diagonal entry, that is 4, 3, and multiply non-diagonality by minus 1. This is become minus 2, this is become minus 7. So what is this value? 1 upon 3 into 4 is 12, 2 into 7 is 14, 12 minus 14 minus 2. This is 4 minus 2, minus 7 and 3. So divide each entry by minus 2. Then it become, so B inverse become 4 upon minus 2 become minus 2. Minus 2 upon minus 2 become 1. Minus minus plus 7 upon 2. Last entry is minus 3 upon 2. This is your B inverse. Okay. Now let us take the another point. What is your theorem? We have to take only statement for that very mark. So write down theorem. If n cross n, if capital A is and n cross n invertible matrix, if capital A is and n cross n invertible matrix, and B belongs in Rn, and vector column vector B belongs in Rn, that is n rows and one column, be any vector in Rn, then the matrix equation, Ax equal to B, then the matrix equation Ax equal to B has unique solution. Then the matrix equation Ax equal to B has unique solution. Unique means one and only one solution. Is, what is that solution? X equal to A inverse into B. What is the solution? X equal to A inverse into B. We have to find A inverse and then multiply A inverse to B column vector. Okay. So today we have to stop here. Remaining part we have to study in next lecture. Thank you.